Good morning, code milkers. Let's check out the problem for the day. It is called valid parentheses string. So, given a string containing only 3 types of characters, an open parenthesis, a closed parenthesis, and a wildcard, write a function to check whether the string is valid. We define the validity of a string by these rules. A left parenthesis must have a corresponding right. Any right must have a corresponding left. Left parentheses must go before right, and wildcard can maybe treated as a single right or a single left or an empty string. So a wildcard can be anything you want, I'm guessing so long as it's at the correct index for the value you want it to be. So let's see. This one is true because it's an open and close. This one is true because open and close, and this wildcard can be an empty string. And then this one is true because open, and we have 2 closed, but we see that the wildcard exists here before the closed, so we can use that. So it ends up being true. So it looks like, rules for wildcard. I think that understanding when the wildcard is used is the biggest problem here. So I want to see, let me just come up with my own little test case here that I think, let's see. In this example, the wildcard's after the parenthesis. Let's have it be before it. Okay. Now this should be false because we don't have a close parenthesis, even though we have this wildcard. And we can't use the wildcard as a closing parenthesis because its index is before the open parenthesis. So we have to compare both of these at the same time. If we wanted to compare both of them at the same time, we could have two arrays with them at the farthest index, like in a stack. That would work. I've done a lot of parentheses problems like this with open and close, so I know one very handy way of doing it is to use a stack to store. So when you encounter an open parenthesis, you push that onto the stack of left parentheses, and then as you go through, if you encounter a right parenthesis, you check if there's any in the bank of left parentheses. If there are, you just pop the last one because that's the closest one that can make the pair with the current left parenthesis. If there aren't any, then you know to return false. This problem's a little different because we can use wildcards to stand for the left parenthesis. So let's think about data structure. We want to use stack, but we want to use, it'd be nice to use 2 stacks. One for lefts and one for I'll call them freebies because it makes more sense to me. So 2 stacks, one for lefts, one for freebies. Then let's see, we're just going to use a for loop to go through the array. Through the string. And our algorithm is init lefts and freebies as empty arrays, for loop, and now on a given iteration, if si is equal to an open, push it onto lefts. If si is equal to a wildcard, push onto freebies. Else, we're going to check So we know immediately that the string is false, so the sequence of parentheses is false if there are no left parentheses in the left stack, and if there are no freebies in the wildcard stack, because we can assume that these left and freebies are at the right index because we're going from left to right. So as long as they're before the right parenthesis, we can use them. So long as both of them are not empty, we don't have to return false yet. So if left and freebies lengths greater than 0, well, for this are equal to 0, return false. And then we want to prioritize popping. We can't pop both at the same time, that wouldn't make sense, because the wildcard is supposed to exist secondarily. So I guess we'll pop the left first. If left's length is greater than 0, pop left. If freebie's length greater than 0, pop freebies. Okay, there's our first for loop. Now we might come out of the string with a few left over. Like it might be yeah, it might be like this one. And this one would be true because this wildcard operator can stand for the right parenthesis. So what would happen would be we would so at the end of the for loop, we would have an array with one open parenthesis and a freebie array of one wildcard. Now, like I've shown in this example here, if the wildcard was before the open, we couldn't use it to validate the parenthesis because it would be like doing this. Which isn't the sequence of parentheses we want. That kind of is shifting the order. And it still leaves. Well, it would work, but I don't think we're modifying it in place. So I don't think we can assume we can modify it in place like that. So I need some way to track the index and make sure that the wildcard is greater than the index of the left parenthesis. So long as the index of the wildcard is greater than the left one, then we can use that as the right parenthesis. So it looks like instead of storing the symbols of the parentheses, we'll just store the indexes. So we'll just store I on each iteration. Yeah, so while, let's see, what's our while? So while, what do we need to be true? So I guess while left's length is greater than 0, and freebies length is greater than 0, because this will break as soon as we don't have any more freebies, and we don't want to substitute any freebies for any lefts if we don't have any freebies left. So if left pop is greater than freebie pop, we want to return false. And we want to do this because if we can see here, in this situation, the index of wildcard will be 0, the index of the left parenthesis will be 1. So wildcard has to be a higher index to use it. And then here, since we'll break out of this loop when there are no freebies left, or there are no lefts left, we'll just return left's length is equal to 0, because really we want to make sure that we're done with the left parentheses. Okay, that looks good. Let's do let lefts, let freebies for let I equals 0, I is less than s dot length, I plus 1, I'm just writing out both the loops here. And then our return value, left's dot length is equal to 0. So we're gonna have a lot of conditionals in here, so buckle up. Si is equal to open, we're just gonna push it onto lefts. Remember, we're pushing the index so we can determine if the wildcard is a valid use case. Else if si is equal to the wildcard, and here we'll do freebies push I. Remember, index, so we can check if it can be used used in a valid way. And then else. So if left's dot length is equal to 0 and freebies dot length is equal to 0, then we can return false. Now when we're in the else, we're in the case that it's a right parenthesis, so we need to check that we either have a wildcard available or we have a left parenthesis available. So here, we want to first check that left's length is greater than 0, we want to pop the left's first. We'll pop left first because it is the primary thing we're comparing. And then if we don't have any lefts, then we use the freebies. Okay, now while if lefts dot pop is greater than freebies dot pop. Remember, in this case, this means that we either have more lefts than we do freebies. I mean, we have more lefts than 0, or we have more freebies than 0, or we have both. I mean, we won't go into this while loop if one of them is empty. So that means that we won't check for freebies if we don't have any there, and we won't check for freebies if the left is already empty, because we know the parentheses are valid at that point. So if the left's index is greater than freebies, we can't use the freebie to justify the parentheses. Okay, past the first test case. let's try an empty string, because that should be true. We'll try that example I came up with, and then we'll try a valid test case. And then another valid test case. Cool. I'll come back true. Let's submit it, see what we get. Yes. Very good. Whew. Blazing fast. Have a great day.